Hello, it's time for math again. We're Module 3, Lesson 8. I am on page 58, the name of our lesson, using if-then moves in solving equations. And so my essential question for today is what is meant by solving an equation, right? What do I mean when I say that? All right, so I'm going to jump into our opening exercise. I want to remind you, and I don't know how much you're going to remember this, but there are some if-then statements. They're kind of conditions that we use in math to help us know some rules and certain things that we know are true. So if A equals B, right? One side of the equation equals the other side of the equation. So if, those two sides are equal, for example, 2 plus 3 equals 4 plus 1, right? Those are equal to each other. Then A plus C, if I add something else to it, is equal to B plus C. They were equal a minute ago. I'm going to add the same number to both sides, then they're still going to be equal to each other. And in the same case, I could do the same thing with subtracting. A minus C equals B minus C. So as long as they were equal to begin with and I subtract or add the same number to both sides, it's all going to work. That is really super handy when it comes to algebra. We use it all the time. Another if-then move that we have is that, again, if A equals B, right? Again, remember, this could be 2 plus 3 equals 4 plus 1. They both equal 5, but they look different, okay? Then, with that being the case, I could multiply both sides. A times C is equal to B times C. I could multiply them both by the same number. And, of course, I can have the reverse or inverse of it. I could also say A divided by C is equal to B divided by C. All right, as long as I do the same thing to both sides. Really, the best way to remember this is what you do to one side of the equal sign, what you do to one side, you have to do to the other. Promise you, if you talk to anyone who's ever gone through an algebra class, they will even be able to answer that. If you said to them, hey, I learned this thing that what you do to one side, guaranteed they'll be able to say you have to do the other. Like everybody just knows that that's the rule, and these are the two if-thens that help us. Okay, so let's take a look at taking 3 plus 5 equals 8, right? We know that that is a true statement, and let's just kind of use it. If 3 plus 5 equals 8, then, and now let's just kind of pick a number. I'm going to say my C is 4, just to make my life easy. Then, now let's do all 4 of these, right? There's 4 different things up there in that if-then statements. Then 3 plus 5 plus 4 equals 8 plus 4. If you have a highlighter, now would be a great time to maybe highlight that you're adding that 4 to both sides. Okay, and if you want to check, you could actually go through and check it. Sure enough, this is 8. 8 plus 4, which is 12. And of course, 8 plus 4 equals 12. So sure enough, it's true, right? So there's one of them. Let's try the second one, in which we subtracted. So 3 plus 5 minus 4 equals 8 minus 4. So in other words, 8 minus 4 was 4, and of course on the other side, 8 minus 4 is 4. So again, it worked. Let's try the third one in which we multiplied. So 3 plus 5, I'm going to put everything in parentheses now, times 4 equals 8 times 4. Okay. Please excuse my dear Aunt Sally. I'm going to do 8 times 4, which is also 8 times 4. And obviously 8 times 4, they're both 32. So that works. That's good. And then let's try the fourth one in which we were dividing, right? So if I take 3 plus 5 and divide by 4, I'm going to write it as if it looks like a fraction, just because I find that to be easier. 8 divided by 4. And again, I can set this up as 8 over 4 equals 8 over 4. In this case, they both equal 2. See, so that worked every single time. Now, purposely picked good numbers to work nicely with us, but even if I had picked really crazy numbers, it still would always work out. All right, so there's just a real example of these statements. These if-thens are vital to algebra. All right, so let's take a look at Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight, right? I know they do this here in South Elgin. You'll see the firefighters walking through the intersection to raise money, and you drop it in their firefighters, those rubber boots, right? So after 1 hour, Keller had collected $42.50 more than Julia, and Israel had collected $15 less than Keller. The 3 firefighters collected $125.95 in total. How much did each person collect? And it says, hey, let's do this using a tape diagram. So those of us who are visual learners, here we go. All right, so I have 3 people. I have Julia. I'm really lazy. I'm not writing her whole name out. I have Keller, and I have Israel. All right, I have these 3. And based on what I have, I'm going to base everything off of Julia. Julia, we don't know how much she has, so I'm just going to make a mark for her. But I do know that Keller made the same as Julia plus $42.50 more, right? And then I know Israel made what Keller made minus $15. So if I go all the way to here, right, and this here is $42.50 minus $15. Well, what is $42? What is $42.50 minus 15? Line up your decimal points, right? 0, borrow, bring that over. Oh, I didn't have to do that. What am I saying, Mrs. Hoekstra? Let's erase that and start over. What's $42.50 minus 15? That's 50 cents. Now I'm just going to borrow from here. That's 7, what, $27.50. So I'm going to just erase that and write $27.50. And I know that all 3 of these is $125.95, right? So what I could do is I can take all this information, I can take the $125.95, and I can subtract the $42.50 that Keller has more than Julia, and I can subtract the $27.50 that Israel has more than Julia. And when I figure this out, I find out that that is $55.95, right? That is the 3 spots that I don't know. So between those 3 spots, I have $55.95. So now I'm going to take that and I'm going to divide it by 3. So I grab my calculator, I type in $55.95, divide by 3, and I find out that it's $18.65. All right, so in other words, Julia, oh, what color did I have Julia? I had Julia as green. I'm going to keep it green. Julia made $18 or raised $18.65. And then I'm just going to plug in $18.65 and the $42.50, and I get Keller. Keller, he has now made, what is $18.65 plus, let's grab the calculator, $18.65 plus $42.50. He made $61.15. And then we have Israel. And Israel, he raised, again, $18.65 plus the $27.50. $46.15. Okay, so what operations did we use in this process? Oh, there's the bell. What operation did we use? Well, we used some addition, right? We use some addition. We use some subtraction. And to get the final thing, we had to do a division. All right, we had to do division. All right. Well, what if instead we had written this using like a formula, using variables instead of doing the tape diagram? Because, you know, some of us don't like the tape diagrams. So here's what we can do. We can say Julia is J, right? We're not very original in coming up with our letters. J for Julia. And so we could say that Julia's money plus what? Keller's money. And Keller's money is Julia plus $42.50, right? There's Keller's money. And then we could say, well, we're going to add that to Israel's money, and Israel's money is Julia's plus the $27.50, right? So there's Julia plus Keller plus Israel. And we know that this whole thing is going to equal $125.95. Okay, we could do it setting it up that way. Let's suppose I wanted to base this off of, instead of Julia, I want to base it off of Keller. Okay, we're going to draw a line here. We're going to add an extra spot. We're going to base it off of Keller this time. So I'm going to use K for Keller. I know, not very original. So Keller, he's the middle guy, right? And Julia raised less money than him. How much less did Julia raise? Keller's amount minus the $42.50. Right? He was $42.50 more than her. So if I base it off of Keller, Keller is the base number. Then Julia was $42.50 less than him. And then we could figure out what it is for Israel. And it said in the story problem that Israel raised $15 less than Keller. And again, all of this still equals $125.95. Okay? We could do the same thing for Israel. Right? Again, not going to be very original. I'm going to use the letter I for Israel. I'm going to use capital I so it doesn't get confusing. All right, so if I use Israel as my basis, right? Israel made what? $15 less than Keller. Or in other words, Keller made $15 more. So Keller, I'm going to leave him in the center there, is Israel's money plus $15, right? There's Keller. I'm always going to put them in the middle. And then Julia made the least amount of money. She made $27.50 less than Israel. So here's Julia, Israel's money minus $27.50. Okay, so again, this is Julia, this is Keller, and here is Israel, right? There's Israel. So nothing has changed. I kept them all in order every time so that you guys could understand where I'm getting these numbers from. Now, personally, not a fan of at least the Israel one. The Keller one I kind of get because they talked about Keller. I really like the Julia one because everything just kind of seemed to be based off of it. So using Julia, I'm going to take this equation right here. Okay, I'm going to take that one and I'm going to bring it down here and work with it. Okay, let's simplify it like we were doing in the first half of this book. So J plus 42.50 plus J plus 27.50 equals $125.95. I took all the parentheses out. The parentheses were there just to show you Julia, Keller, and Israel. All right, so how many J's do we have? I have a 1J plus a 1J plus a 1J, right? I have 3J plus, and I'm just going to leave my numbers out here for a second because I think it might be less confusing to you all. Okay, just rewrite it. I just added the J's all together. If you need to, draw an arrow so that you see where that came from. Don't get lost. All right, next thing I'm going to do, I'm actually going to add those two to each other. So I now have 3J plus, oh, that's 70. That's kind of nice. Equals 125.95. Now, I want to use one of those if-then statements from the other page. Okay, I know that these two sides are equal. You know how I know? Because there's an equal sign that says they're equal. Well, I want to pick, I want to subtract a number from both sides. And I could pick any number I want to subtract, but I'm purposely going to subtract 70. 3j, I'm purposely going to subtract, and I'm going to put it, I think, in red. I'm purposely going to subtract 70. And you're going, well, why in the world would she purposely pick the number 70? She could have picked any number. She could have picked a million. And I could pick a million and subtract it from both sides. But the reason I like 70 is because what happens when I have a positive 70 minus 70? What happens with that spot right there? It becomes 0, right? This here is 0. And remember I told you guys all semester we like the number 0. It's very powerful. So I now have 3j is equal to, and then I just do the subtraction on the other side, which is 125, oh, excuse me, I apologize. It is now what, 55.95. Let me back that up. Erase this. It's 55.95. That's 55.95. Isn't that interesting? I wonder what I could do with that. I could use one of those if-then statements, and I can divide both sides. I could divide both sides by any number in the entire world that I so desire. I desire to divide by 3. So I'm going to divide this side by 3 and the other side by 3. What happens when I take 3 divided by 3? Over here on this side, 3 divided by 3 becomes the number 1. Aha, remember, again, I told you all the number 1 is a powerful number for us. I just made the number 1 there. And then I take 55.95 divided by 3, and sure enough, I get $18.65, just like I did when I did the tape diagram. The tape diagram is using arithmetic. This is using algebra. Okay? All right, let's go to page 60. Basically, this is more of the if-thens, right? So we used what statements? We used the subtraction, and we used division to help us with it, okay? All right, example 2. You are designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. You decide that you would like the length to be 6 1/3 feet longer than the width. Okay, draw and label a diagram. Soon as you see or mention, have anything of a shape, you should automatically just go, okay, I'm going to draw this out. I just want to have some idea of what's going on. So just draw yourself a rectangle, okay? And it mentions that you're going to use fence. Is fence the perimeter, or is fence the area? Well, they're not asking about the space that your dog is going to have. We're talking about perimeter. Okay, so when I think of perimeter of a rectangle, I'm just going to write down things I know. Perimeter is length plus width plus length plus width. Or maybe you know it as 2 lengths plus 2 widths. Or I could say it's 2 times length plus width. All of these are ways to write perimeter. Any of those are fine. Just kind of get your brain thinking about it and write down the formulas that you know. Okay, so I also know that the length is longer than the width. Well, I don't know what the width is. I'm going to call it W. Don't know it. Just write W. I do know something about the length. The length is going to be 6 1/3 feet longer than the width. So if I add 6 1/3 to the width, I'll know how long the length is. Okay, all of that just from the sentence and just drawing it out and get your brain thinking. So it says find the dimensions of the pet pen. So I'm going to use one of these formulas that are up here. I am going to actually use the middle one. Okay, I'm going to take that one. But you could use any one. P is equal to 2L plus 2W. Just going to write it down. Now let's take the stuff that we know from up above in our drawing. What do we know? Well, we know W is W, but I also know that L is all of this. And I'm going to drop that in. All right, so perimeter is equal to 2 times 6 1/3 plus W plus 2W. Okay, I'm literally just going to drop those into those right spots. Again, if you're working with a highlighter, maybe what you'll want to do is highlight the 6 1/3 plus W, and then highlight it in the equation that I just wrote, and same thing with a W on the side, and highlight that in, right? Grab your highlighter and highlight this, and highlight it in here. And then grab a different colored highlighter, highlight this one, and highlight that one. Or if you're working in different colored pencils, make it so that these jump out as to why in the world did Mrs. Hoekstra put those in that spot. Okay, well, when I see a number on the outside of the parenthesis, I instantly go, aha, distributive property. 2 times 6 1/3 plus 2 times W plus 2 times W. Oh, that's kind of nice. That works nicely, doesn't it? 2 times 6 1/3, don't freak out. You guys hopefully have gotten good at working with your fractions. 2 times 6 is just 12. And 2 times 1/3 becomes, 2/3. Look at that. Amazing. Plus, what's 2W plus 2W? That's right, 4W. Well, that's pretty easy. Okay. By the way, how much fence did you have this whole time? This whole time you've had how much fencing? 30 feet, right? You have 30 feet. So I'm going to drop in 30 into the problem now, where the P was. I'm just going to drop that in. And this is now going to equal 12 2/3 plus 4W. Well, they're equal to each other. I know that because of the equal sign. I want to move 12 2/3. I don't like it there. Not a fan. So I think what I'm going to do is I'm going to move it to the other side. And in order for me to do that, I'm going to subtract. Now this time I'm going to write it down below because I do like subtracting vertically more than horizontally. Okay, it is still using those if-then moves. I'm going to subtract because that's if they're equal, I can subtract the same number on both sides because what I do to one side, I have to do the other. The other reason I like to do it this way is because then I can cancel those out. That just becomes a 0 and it makes it really easy. 30 minus 12 is 18, okay? 30 minus 12 is 18, minus 2/3 becomes 17 1/3. And that is going to equal, and what do I have left on the right-hand side? Just the 4W, because the 12 2/3 are gone. All right, that's 4 times W. How could I find out what just plain old everyday W is? I could divide both sides by a number. What do you think I should divide by? I'm going to divide by 4 because I love the power of the number 1. And even if I draw it like that and do my division this way, I can divide it and look at that. I got a 1 and a W. 1 times W is just that. It is W. Yay, that's what I want. 17 1/3 divided by 4. I'm going to be nice. I'm going to do the math for you. It is 4 1/3. All right, so if width is 4 1/3, what is length? Well, length is 6 1/3, excuse me, 1/3 plus 4 1/3. Well, 6 plus 4 is 10. 1/3 plus 1/3 is 2/3 feet. And there are the dimensions of your puppy's pen area. All right, let's go on. Nancy's morning routine involves getting dressed, eating breakfast, and making her bed. Right? Oh, and then driving to work. Nancy spends 1/3 of the total time in the morning getting dressed, 10 minutes eating breakfast, and 5 minutes making bed. And the remaining time is her driving to work. If Nancy spent 35.5 minutes getting dressed, eating breakfast, and making her bed, how long does it take her to drive to work? Okay, well, we're going to start off by using, I'm going to actually kind of start with a tape diagram just to kind of help me get a visual of what's going on. Okay, so it says that she spends 1/3 of her time in the morning getting dressed. 10 minutes of that time is eating breakfast, and 5 minutes is making her bed, right? So I'm going to draw myself a rectangle. I'm going to break this up into 3 parts. It doesn't have to be 3 equal parts, okay? Because I know 1/3 of her time that is unknown to me, right? So I'm just going to put that as an X, 1/3 X. is the what? Getting dressed. She spends 10 minutes. I know that piece there is 10 minutes, and I know one of these pieces is 5. Like I said, they don't have to be equal sizes because obviously 10 and 5 are not. But I do know that this whole thing is 35 and a half. Okay, so it kind of gives me some idea of what's going on. So I'm just going to write this as 1/3 x plus 15, because I can put those two together, equals 35 and a half. I know these are equal, so I can do different things to both sides of these. So since they are equal, I think I'm going to subtract 15 from both sides. And when I do that, it creates this beautiful number over here on the left-hand side. I still have the 1/3 x, but the beautiful number is 0. Okay? And then when I subtract 35 and a half and minus that, subtract 15 from it, I'm going to have what? 20 and a half. Okay? And then I've got this 1/3 x. Well, all of the other problems that I've done this, I have divided by 3. Well, I can't divide by 3, or divided by our number. I could divide by 1/3, but dividing by 1/3 is the same as multiplying by its reciprocal. Multiply by 3 over 1. Totally legal. Multiply by 3 over 1. Again, you all have the wonderful power of a calculator, but what happens when you multiply those two numbers? They're multiplicative inverses. It becomes the beautiful, wonderful, lovely number 1. This becomes 1x, or just plain old x, and then I can multiply 20 and a half times 3, and I end up getting 61 and a half. So in other words, x equals 61 and 1/2, and this is what? Minutes. Well, that's the x part of it, and we want to know how much is driving. So the whole time it takes for her to get ready is 61 and a half. That's including the driving. So let's take out the amount of time it takes to get ready. And when I do that, we find out it takes her 26 minutes to drive to work. Okay? Does it sound like it makes sense? Yeah, it makes sense to me. It's pretty reasonable. All right, page 62. I want to get through this lesson. The total number of participants who went on the 7th grade field trip to the Natural Science Museum consisted of all of the 7th grade students and 7 adult chaperones. 2/3 of the participants rode a large bus, while the rest rode a smaller bus. If 54 of them rode the large bus, how many students went on the field trip? Okay, so we can do this with the arithmetic approach and the algebraic approach. All right, so for the arithmetic approach, I am going to draw a tape diagram. Okay, and we know that 2/3, so in other words, I'm going to break this into thirds. 2/3 of the kids were on the large bus, right? Large, and this would be small. Okay, oh, and by the way, part of that small group, we have to include the adults. How many adults did we have? We had 7 adults, so I'm going to toss that in there as well. Okay, I also know that the large, that whole group right there, right, these people in these groups, that was 54 kids. All right, so what is 54 divided by 2? Right, 54 divided by 2 is 27. So each of the large buses was 27. 27 kids, 27 kids. Well, remember, this is all split into equal pieces, which means this also has to be, the whole thing has to be 27, right? But 7 of them are adults. So how many kids were on the small bus? That's going to have to be 20, right? 27 minus the 7 adults gives me my 20. So how many kids do we have all together on the whole trip? So we have the 54 on the big bus, plus the 20 kids on the small bus, for a grand total of 74 kids. There it is, using arithmetic. But I put my big kid pants on and I teach algebra. So here we go. I could also look at it using algebra. I know that 2/3 of all of the kids, right, we're on a bus. A bus is the small bus plus the 7 adults. Okay, And I know that that large bus equals 54 kids. All right, so now that I have this set up, I could distribute if you would like to, but I don't think 2/3 times 7 is a nice number. So what I'm actually going to do, I'm actually going to work this problem differently. I am going to use the if-thens. I'm going to get rid of the 2/3. And in order for me to get rid of the 2/3, I'm going to multiply both sides by its reciprocal, the multiplicative inverse. I'm going to multiply both sides by 3/2. All right, that makes this all become 1. And I have 1 s plus 7. And that's going to equal whatever 54 times 3/2 is, which in this case is 81. Okay, grabbed my calculator, did the math. All right, well, 1 times s doesn't change anything. So this is really just s plus 7 equals 81. Could I solve for s? Yep, I can subtract a number from both sides. That's one of those if-then statements. I personally am going to subtract a 7. It's going to make my life easier, but you could pick any number. But I don't want to. So s is equal to whatever 81 minus 7 is, because these two 7s cancel out and give me the beautiful number 0. 81 minus 7, sure enough, s equals 74 kids. So yes, the arithmetic, you did do all the exact same stuff I did on the algebra side, but I can get to it rather quickly. I don't have to do a whole lot, but they are going to do the same thing, but we're headed towards algebra. You have to start saying goodbye to the arithmetic and hello to the algebra. All right, I will chat with you guys in class.